Hello friends, in today's video I'll be showing how did I made this Robo Car and what are the challenges I faced while making this Robo Car. So let's go on to the video. This is my plan where I have briefed out my different role in making the robot. So the roles are divided into mechanical, electrical, and programming. So the mechanical work is divided into three, which is design, fabricate, and assembly. In electrical, battery management system, which is BMS, wiring and soldering. In programming, I use C and Android for controlling via from my app is like futuristic plan, which I have would do if I have a time to do it. I'll be doing it, or else like it will be a on hold thing. So with this everything integrated, I'll be testing my robot and I will be showing how do I do it, how I did it. So let's go on to the design. So this is the design which I have sketched in my notepad. So basically in this design, what was my main focus was in designing a part which is less in size, less supports, and it is easy to 3D print it because 3D print is the easiest method and it is a suitable method to make the body in a faster way. So I should have a body which prints in a less time and has less support, and it should be easily uh, usable and fixable. So that's how that is why I have came with the design. So this is the side view and this is the top view of the robot. So I'll show actually this is the design. Right now I'll show the 3D model of the exact design which I did in Fusion. From the good practice of engineering, it is important to have a design in a sketch to visualize ourselves about the robot and design further in a CAD model. It is easy for us to know what can be done in a paper before I can do it in the model and change the whole history of it. So, as per to the good practice, I designed in a paper and to visualize how my robot would be. Then I went to the CAD model and started to design in Fusion. Then I have my robo dimension criteria. So the robo should be within a particular dimension. So I will talk about the dimension which are in which my robo should be within its bounded within itself. So the length of the robo should be 140 mm and the width of the board should be 130 and the height of the board should be 100. So with the dimension criteria, I have made my robo with which like I have designed a robo which fits in the dimension. This is the rough dimension of my robot, the body of the robot, which I have designed from the parts after assembling. So this part is quite easy to print because it has very the thickness of the part is 3 mm and the thickness is uniform throughout the area, throughout its body, except the portion where I fix the caster wheel is bit thicker holes, so I can pass through the wire between the holes and fix it. So there is a battery holder where I can place my battery, and this is a controller which I'll be using over here, and I have placed a two breadboards where in the future I'll be connecting some sensors and a switch on off switch and a fuse. So this design is really a basic design and it is easier and faster to print by any 3D printer. There is no any complicated shape over here and it is quite feasible to print in one print without any supports. To print this part, I am using Prusa slicer to slice the part and convert the S I have exported the part into STL. So uh, from the fusion. I have exported the body parts into STL. Then I have opened the STL into the slicer software, which is Prusa, and I have kept default setting. So the default setting is like zero point 0.3. Uh, yeah. So this is the layer height, and uh, I have I have supports only for the compliant mechanism, which is holding the battery to hold the battery. And other than that, it is like easy to print. There is no overhangs or there is no any other things. So it is quite 1 hour print, and these are the two body parts, which is the this part is for the larger breadboard holder, and this part is for the battery holder. So next we will slice and see the body and see how what time it takes. So this is the main body of the car, Robo Car, and you can see there is no much more, like there is no overhangs in the print, and the this holes are for the nut to embed, so I can just screw it in. Yeah, so there is easy enough print, and the print time it takes is like 2 hours, which is not so bad. I can it is a good time. So let's we print it out and try to assemble the parts. Parallelly, while assembling, I also started to do my coding in an online emulator called Walkwe. This website is a very cool website where I can emulate my code without touching any physical component. So I have written my code in Walkwe. This online emulator is called as Walkwe, where I have written my code in C and tested how it works. It helped me to make my work very fast, so I can test my code put and before I connect, do the all physical wiring stuff. So for example, I can test it over here, serial print screen. So it is working. So let's burn the firmware and test it out. After assembly, I came to notice my controller board has been damaged, so I can't program this board. You can see from the picture the micro USB has been broken down. So after After searching through the internet how to program your controller if your micro USB is damaged, then the internet the people suggested to program via ISP, which is in circuit serial programmer. So with that you can directly flash your program into the IC and you don't need support of USB serial. So for that I got a pocket serial programmer which is USB tiny to flash this controller. So let's see how to flash the controller. After connecting the ISP programmer and trying to flash the IC, that time I was not able to flash it because the controller was bricked. So I was not able to flash via ISP. As the controller was bricked, I need to make a new controller which is equivalent to the old one, and I need to do to complete this project. Um, so to overcome the issue of the controller, I have made my new circuit with Arduino Nano. So I'm using Arduino Nano and L293D motor driver, HC05 Bluetooth module, and LM80 LM7805 voltage regulator to regulate 5 volt to the Arduino and power the HC05 Bluetooth module. So the two motors are connected to the motor driver and it is totally powered from a lithium ion battery of 12 volt. So this is the circuit diagram and this is how I have did my controller to overcome the issue of the brick microcontroller. After programming my DIY controller, I still face some issues while testing my car. Major issues from the mechanical side only. So one of the major mistake I have did while while designing is I didn't take the necessary dimensions. For example, the mounting holes are the necessary dimension in a component or than their shape and the feature, which I have missed out. And second thing is visioning your design till end of your assembly. So I have visioned my design during the sketch phase. So after it is printed, after I 3D printed the parts and after the assembly, I had changed the controller from the Romeo controller to the DIY controller. After the change of the controller also, I need to have the vision. So lack of the vision made to do some DIY stuff where it unnecessarily wasted my time in correcting the issues. And second and the third thing is apart from the designing time, also need to understand the real time factor which can affect the robo while moving. For example, friction. I have placed the wheels so close to the body, so due to the friction, it had some issues while rotating the wheel. So I need to consider the real time factors also, and I need to place some clearance between the wheels so it can move freely and reduce the friction. So after without the proper vision, I have practiced I had did some wrong assembly practices which took long time to rectify the issue. One of the issue was I have drilled the wheel. So so while drilling the wheel it is necessary to maintain the concentricity. So while drilling, manual drilling will make the concentricity lose point 0.1 or point 0.2. Due to that, a wheel if a wheel doesn't has a proper concentricity, it tries to wobble around. So my car also has the wobbling effect. So the wobbling effects increased increase the chance of moving, like not making the car to move in straight, but to turn its change its direction while moving. So so these are the mechanical factors which I need to rectify, or which I need to cut it down while I make a new prototypes. In the terms of electrical side, I need to debug why I was not able to move backwards. But as per to the datasheet of L293D, the motor driver, when you reverse the polarity, or when you reverse the input signal, it allows your output to go backward. But I don't know why it happened. Maybe there might be a diode in the motor which stops the reverse flow, backflow of current, and preventing the motor to turn it backside. So I need to debug that. And in the terms of programming, still my code can be efficient enough, and it can perform better. But uh, I need to make it a little more efficient. And while the mechanical and electrical problem caused me a major issue, I failed to learn about Android, how to use Android and how to make apps in Android. I thought of making my own app to control the robo from my own app. So due to these two constraints, I was not able to learn about the Android, making apps in Android. So that eventually affected my learning. At last, I have successfully made my car to go straight by controlling the speed of two motors, and I have made it. I was able to transmit my signals through Bluetooth from my phone and able to control my car. In the end, by doing this project, I think I have learned all three cores of the building a robot, which is mechanical, electrical, and programming. In upcoming videos, I try to be more informative. If you like my video, do try to like my videos and subscribe to my channel. I hope it was informative to you, and I hope you learned something also. Thanks for seeing my video. Thank you all.